Hello, everyone. I'm Wei Chunyue from ShanShui Conservation Center, and we have our colleague Dongzhi Yi also in the meeting room, and we hope to share some of our work on AI-assisted camera trap management with you. And as you can see, I'm currently in a car now, so maybe the internet connection may not be that stable, so you can interrupt me at any time if you miss some of my presentation. And thank you for your understanding. And this is our content for sharing today. So first, I'd like to briefly introduce the camera trap data workflow as background information for the tools we're developing. And then I will introduce some of the tools we are currently developing that includes AI tools for the data processing, basically to identify the animal species in the camera trap images and videos. And also we are developing a data management platform that can store the data on a cloud platform and enable multiple users to process the data online, and also enable us to have a thorough view of the whole database. And lastly, I will introduce currently the application of such tools and our future plans for tool development. And here's a brief overview of the camera trap working flow of Shan Shui Conservation Center. We have more than 1,000 camera traps deployed in multiple regions in China, and most of them, some of them are for baseline survey for short term, and others have been deployed in the field for a long time, and they are used for long-term monitoring to see the trend of animal population change. And as you can see, we have a huge data set of the camera trap data. We have over 25 images and videos, and they are updated pretty quickly. So we have many data. We have many data collected each quarter. And for our camera trap monitoring work, we also have multiple agents involved in the monitoring work. So in the Sanjiayuan region and also in Tibet, we have local herders. We invite local herders to act as the camera trap monitors. So they are in charge of the camera trap setup, pickup, and also the maintenance of such camera traps. And well, in the cities, for example, in Beijing, Shanghai, and other cities, we have citizen science. They are assisting us with the camera trap maintenance and also the data processing. And also we have camera trap data management staff from us, ShanShui. And also we have species identification experts. They will provide useful opinions for us to verify and to verify the species identification results and to enhance the accuracy of the camera trap data processing results. So under this background of a huge data set and also multiple agents involved, we are thinking how can we improve the efficiency of the management of our camera trap data. So we have sorted out a general camera trap data workflow, which I believe most of you are already very familiar with. So firstly, in the field, we need to have pre-planning and training of the staff, and then we have an in-field data collection, which which will cost like 2 to 3 months. And after we collected the data from the field, we need to organize the data like into a structured database. And then we transfer the data like mostly using hard drives to a central database where we have staff or we have other citizen volunteers that can process the data. And then we move on to the long data processing period. So basically we use human labor to process the data, like to identify the species and also snow leopard individuals in the camera trap images and videos. And that process would take a pretty long process. So maybe like camera trap data for 2 to 3 months, we will need another 2 to 3 months for human to identify the species in those camera trap data. And after the long data processing period, we will archive the data. Like we need to check if the data, if we miss some of the important data, and also we can delete some of the blank images like that are not very useful for our future analysis. And after the data archive, we move on to the data application step. Like during this ongoing process, we mainly have so during this period we use the original camera trap images and videos, mostly the featured, like the images of high quality for dissemination purposes, while also for apart from the images themselves, for the tables and the data we collected from such images, we use such data for further scientific analysis and also for summing up our working efforts and help to inform how should we do further analysis, further survey and monitoring, and also help to inform conservation decisions. So yeah, and we find some of the problems, like the major problems we think during the whole workflow is during the data processing process. Like it's time consuming and labor consuming process. So we are hoping to using some AI tools to assist this process. And also for the overall workflow, we're hoping to use a combined data management platform to help us manage the data during the whole process. And as such, we can manage our data more efficiently and to have a central database for the data, and so that we can use the data more conveniently. And moving on to the data AI tools we developed for the camera trap data processing process. So the general workflow is that first, the background is that almost half of the camera trap photos are blank photos without animals, and sometimes the proportion would be much higher, like it can reach 80 or 90%, like 80 or 90% of the camera trap images are blank photos. So it's important to filter out such blank photos from the further manual identification process, and that can save a lot of time. So the general workflow is that for AI to first detect animals in the images, and and after such detection, we can remove the blank photos. And for the animal detection process, we already have like it's not we like there is already some models that have high accuracy for the animal detection purpose, and that these are for example, the mega detector model. It is trained using a large training data set, and this data set includes a variety of ecosystems, so it can be used for camera traps deployed in different environments, and also it has accuracy of 90 to 95%, so that it can efficiently help us to sort out the blank photos. And after the animal detection process, we move on to the species identification process, and we have some AI models trained for the Sanjiangyuan region, or in other words, the areas where snow leopards are present. But for such models, a problem is that the training data set is limited, and such limited training data sets, such limited training data set also limits the accuracy of such model, which is approximately 60 to 85%. And also such species identification model supports like 10 to 30 species. And after the AI species identification process, we may also have AI individual identification and even behavior identification models, but such models are currently under development, and hopefully we can have such models in the future, but right now we don't have reliable models for such purposes. So like after the AI processing, we have as I said, the accuracy of the AI models is not 100%. So we need manual recheck after the AI identification. So after, we firstly have the citizen scientists. They as volunteers to join the species identification process. And after they identify the species, we then have experts to review the identification results, particularly the inconsistent result and also unsure results from the citizen scientists. And then we can, after such a process, we can get a more accuracy camera trap data processing results. And firstly, I will introduce the AI animal detection process. So for the model, we currently use the Mega Detector AI model, which is developed by Microsoft AI for Earth program. And it is an open source model, which means that anyone can use that model. And I put the URL here for anyone who are interested in the model. So the model is trained on millions of camera trap images from a variety of ecosystems, and it is continuously improving with more training data set input. And also the model changed from faster RCN to EULA v5 in 2022, which makes the model more not only more accurate, but also runs more faster. And the model, the classification of the classification results of the model would be blank, animal, or human, or vehicle. And also it can draw the bounding boxes of the animals in the images as these images show. And an important part of using AI is to select a threshold for the AI identification. And here shows a basic concept for the AI animal detection. So basically, we would like accurate result of like true negative and true positive, which means that the image itself actually don't have animal, and the detector also says it doesn't have animal, or it has animal and the detector says it has animal. And there are some error situations that we do not like to see. And the situation we least like to see is false negative, which means that the image itself has animal, but the AI detector says it doesn't have animal. So which may cause us maybe to miss a snow leopard in the image. And this is the situation we least like to see. And another situation is that the image itself doesn't have animal, but the AI detector says it has animal, which is like a false positive situation. We also wouldn't like to see such situation, but such situations are more acceptable compared to false negative situation. Like for false positive, the impact of such errors is that we need to manually recheck some blank images, like to add more efforts for the human identification process. But actually, it doesn't have much impact on the accuracy of the whole data processing process. And here shows a brief example of how to select a threshold. So here shows, for example, if the actual data, it includes 10 blank images and 10 animal images. And if we use a low threshold, for example, 0.1 for the AI identification, it will have smaller number of images, be like smaller missing rates. Like for example, here shows only one image with animal is classified by the AI as blank images. So we have a false negative rate as 10%. On the other hand, it will also have some false positive situations, like the animal, like the AI, like the low threshold means that the AI, like the threshold for AI to identify an object as animal. So if the threshold is low, the AI may identify other objects that are similar to animal as animal. So that will cause the false positive situation, like the actual blank images will be classified as animal images. So in this case, it has a false positive rate of 30%. So in general, a low threshold means that we have low missing rate, but also more blank images be classified as animal images. So low threshold would be more suitable for precise identification, like when you would like more accurate identification results. While another case would be if you select a high threshold, for example, 0.5, and in that case, the threshold for AI to identify an object as animal is high, so it will miss some of the animals, so the missing rate will be higher. And in this case, it misses three animal images, and with a false negative rate of 30%. But the but an advantage of using a high threshold is that it will have lower false positive situations, like the blank images that are wrongly classified as animal images. Such rate will be low. So the first so in this case, the false positive rate is only 10%. So if you are using a high threshold, you would have smaller number of images for to be classified as animal images, and like smaller number of images for human recheck. So it will be suitable for fast screening of the camera trap data, but with the risk of missing some of the animals. And here shows some of the model performance during our testing. So we test the model in different regions in China, like in Sanjiangyuan, the habitat would be the habitat is mainly alpine meadow, and in Sichuan and in southeast Tibet, the habitat is mainly forest. And in Beijing, in the city, we test the model performance on wetland habitat. And in general, the false negative rates of the AI models, we conducted the testing using a threshold of 0.1, and which this is actually the threshold we would suggest you to use, like because it enables the it will have a higher accuracy. Like it misses less animal images, so we'll have a higher accuracy for data processing. And the result of our testing is that the false negative rates in meadow and wetland habitat is 5 to 7%, and in forest habitat the rate is pretty low, like 1 to 2%. And also, the majority of the missing detections are small size animals like birds, rodents, or pika. And we, like as shown in the image, on the right, can you find the missing animal in this image? Yeah, it has an animal, but the AI misses it. And I think it's like, if we just look at the image, it's hard to find the animal itself. And yeah, here is a small pika the AI model misses. Yeah, and so based on the fact that the missing detections are mainly small size animals that actually are not as important as the large and medium-sized animals, like for long-term monitoring purposes, and also for the biodiversity survey. So we think such a missing rate or such a false negative rate is acceptable. And on the other hand, the false positive rate ranges from like it's generally 20 to 30%, which means that the AI model can effectively remove like 70 to 80% of the blank images, while leaving the rest of them for manual recheck. And such cases mostly happen for the object that has similar shapes like similar shapes like animals, such as stones, fallen leaves, and other similar projects. And also such wrongly identification commonly happens for a series of images that are continuously misidentified. So during our manual recheck process, we can conveniently remove those blank images from our manual identification. So generally, we think the AI animal detection model suits our needs, and it has an acceptable accuracy, and also it can efficiently help us to filter out the blank images from manual identification. And we use such AI models to develop some tools to for the convenient usage of such AI models. And here shows the web tools we have developed. And here shows the user interface of the tool. Sorry, it's all in Chinese. We will try to translate it into English soon. And also the web tools is only for images, due to various reasons. Yeah, because detection for images is easier than for videos, and also videos may consume a lot of time for the AI identification. So currently the web tools is only for images. And here shows the general user interface, and also the results page. And here is more detailed introduction of the functions of the web tool. So firstly, you can upload images, and for this process, you have two options. So option one is that you can upload multiple images, and option two is that you can upload multiple folders. Like each folder for each camera trap contains various images, and this option helps to keep the local directory structure, and is more useful for massive data processing. And then moving on to the AI identification process, you need to, as I said before, to select a threshold for that are suitable for your purposes. And the general speed of the AI identification process is about 3 to 4 images per second. So it's pretty fast, and you can upload images and wait for the AI to identify the images for you, and then download the view and download the results. So for the results parts, we also have 3 options to download the results. Sorry, it's all in Chinese. So the first one is here, like you can download the images with bounding boxes the AI draw on the image. That may help you to find the images, to find the animals on the images. And option 2 is download the original images with animals. So it already filters out the blank images, and you will only download the images with animal. And option 3 is that you don't download the image itself, but download a result table that includes the file name, and also local directory path, and also AI results, and also the image date time as shown here. Yeah, you can directly use the result table for further manual identification. And we also have we also have a local allocation tool that can help separate the images with AI classification results. So it can sort blank images in one folder and animal images in another folder, and others like human or vehicle images in another folder. And here shows the user face of the local allocation tool. And here is a video showing how to use the tool. Sorry. So first, upload image, and option 1 is to upload multiple images. And option 2 is upload multiple folders. So each folder, it has images in it, and you can upload a main folder that contains multiple folders. And then you will need to select a threshold. The default threshold is 0.1 as we suggested, and then wait for the AI identification. Like you can just keep the web page here and work on other stuff, and then get back to the web page to see the results. Yeah, here shows a library of the AI identification results, like showing the bounding boxes around animals. You can view the results here, and also download images or download the result table. Yeah, it's a pretty simple tool. Oh, and also we have the web tool open for trial. Like random users can upload and identify 100 images per day, and if after such trial you after such trial you are interested in using the web tool for massive use, you can please feel free to contact us. You're more than welcome. You're more than welcome to contact us, and we can assign the we can assign accounts, and also that has higher that can identify higher numbers of images per day. And we have also developed desktop versions of the AI detection model. So here are some processing speed for reference. Like for laptop, the processing speed is not that fast, but if you happen to have a GPU, the processing speed would be much higher, and you can use the GPU to run the AI models on your computer. And currently we have the desktop tool developed using command line and also local application. And here is the user menu in Chinese. And there are also other tools that are available for using the AI models on your desktop. And for example, the Mega Detector GUI and Eco Assistant. And here are the URLs of such tools. And yeah, so basically we would like to share how to use the AI web tool here. Yeah, so here is the tool. Here is the tool itself, and you can upload image just by point this button, and yeah, and this is upload multiple images, and this is upload multiple folders. So let me share how to upload multiple folders. So basically, I have 2 folders in the test folder, and in each folder, it has several images. And in this case, you can just upload the test folder that containing the multiple folders that you would like to upload. and yeah, just point upload. Yeah, and here is the threshold for like you can choose your own threshold, and the default option is 0.1 as we suggest, and then point start identification. And yeah, pretty fast for 18 images. And here shows the general results, like total number of images is 18, and it has 8 images with animals and 4 blank images and 6 other images with animals or vehicles. And here in this page, it only shows the images with animals or with humans. And as you can see here, it has bounding boxes of animal and also a person. And animal. And as I said before, the first option for download the AI identification result is to download the results with bounding boxes, the images with bounding boxes. It may take some time to zip all the images together. So in this option, you will have all the images uploaded to be downloaded. And here are the blank images. And here are the animal images with bounding boxes. And the second option is to download the original images that has animals in it. It has the original directory structure as the structure in our local desktop. And here it only has the animal images here. And filtering out the blank images, only animals and human images, or only animal images. And the third option is the option we would suggest you to use. Like do not download the image itself, but just download the identification results as a table. So here shows the local directory path of the image and the file name of the images and the AI results as category. And also it can extract the date time of the images. And for the local data allocation tool, let me show you how to use the tool here. So the tool is also pretty simple to use. So you just need to select the local folder that you uploaded into the into the Web2, which is the test folder. And here you can upload the result CSV as we just downloaded the data. And then you can just organize the images. As you can see, here we have the images classified into the animal folder and the blank folder. And in animal folder, it only has the images classified by AI as animal. And in the blank folder, these are the blank photos. And after such allocation, you can just review the images in the animal folder. And after you completed the manual identification, you can use the redo function to making it to remove the animal and blank folders and make the data structure back to the original state, like just images in the folder for each camera trap. Yeah, and that is a brief like a pretty simple practice. If you have problems, you can put it in the chat box, and yeah, I think my colleague Zhengyi are answering such questions. And moving on, so we're moving on to animal species and identification. So after the animal, animal detection, like in other words, the blank image filtering out process, we use AI tools to help us identify the species in the camera trap images. So here we are sharing two of the models that we and also our technical partners that have developed for snow leopard and its sympatric species. So the first one is the AI models developed by Tencent. I think we also have our Tencent partners here in the meeting room, and yeah, they are using their technical capabilities to develop such AI models for to help conservationists process the camera trap data. And another model that we collaborated with MindSport to develop is also for Sanjiayuan species, and such model and this model is just a small model for to test if the species if such AI species identification model can work. So this model uses a smaller data set, and also it supports a smaller number of species. So basically today I will briefly introduce the Tencent AI model that has that are using a more training data set, and also it supports I think 31 species, which and also has a higher accuracy. So for the Tencent AI model, it actually can not only identify species, but also it enables animal detection. So so this model can also help filtering can somehow help filtering out the blank photos. And also Tencent, they are trying to develop some supporting AI models for the individual identification process, which I will briefly introduce later. And some of the challenges for AI model training as identified by Tencent during their training process is that the animals on the camera trap images are commonly small objects, and they are pretty similar to the background, which means that AI is harder to find such animals. And also the classification task also have more problems, like there are some species that are pretty similar to each other. For example, red fox versus Tibetan fox. So such fine-grained image recognition task would also be a challenge for the AI model training. And also there are new species that are not included in the training data sets due to the data constraints. So such new species will also cause some challenges for the AI model. And also the AI model need stable performance for various situations, like during daytime, during nighttime, and during rainy or snowy days. So generally, the challenges for AI modeling are the first of all, the training data is severely lacking and unbalanced. So we have more images that for animals that are that have higher relative abundance index, but for some animals we only have few, maybe tens to hundreds of images. For this species, it's hard to train the AI to identify such species. And also the animal scales varies, like there are large animals and small animals. And also the background for each camera trap changes greatly. And also as I explained before, there are large differences within classes and small differences between classes that may cause the classification problem harder to conduct. And there are also various qualities of camera trap data. For example, there may be some occlusions and also some difficult samples to identify. So generally, based on these challenges, we will need an AI model that have a generalized identification process for across various situations. And Tencent develop several solutions for such challenges. I will just briefly go through them. So first of all, for the data construction, they use multiple data augmentation methods for the object detection. And also they use multiple models in several steps to enable a more accurate identification results. So first for the binary classification network, it's similar to the it's basically the animal detection work, as I said before, like to classify the if a camera trap image has or has not animals in it. And after the binary classification, they has a multi-class classification network to determine the class or the class of object or species that appear in the camera trap images. And also they have optimizations in the training methods to help achieve the purpose of more balanced training, to solve the problem of the imbalanced training set of different species. And here are an overview of the Tencent AI model. So they are continuously developing the model, and through multiple iterations, the performance of the model improved a lot. So from the version 1, the training data is 30,000, and moving on to version 3, it has 130,000 training data, and the species number also increased from 23 to 31, and with a general the general indicator of the AI model performance, the MAP, increased from 0.395 to 0.678. And if we look at the snow leopards, the accuracy of snow leopard identification also increased from like about 60% to 85%. And the recall rate of snow leopards, which means that the actual snow leopard images that the snow leopard, the actual snow leopard images that are classified as snow leopards is the rate has been increased to 95%, and also it has the function of blank image detection, as it can help filtering out 50% of blank videos and 70% of blank images. Yeah, and a great kind of advantage of the AI model is that it not only supports images but also supports videos. And on the right, it shows the mean identification rate of the 31 species. And these species include snow leopards and blue sheep and other its sympatric species. These are in Chinese pinyin, not in English. Yeah. And here is the species identification user interface that Tencent has developed. And here shows a video, and the user interface, not the user, each video is for each video, the processing process is that it is divided into various screenshots, like to take a screenshot per second, and for each screenshot, the AI model identify the species in it, and here you can see the results for each screenshot, and to manually recheck the result for each screenshot and also for the whole video. And as I said before, another model for AI species identification that we have been developing is that the MindSpore AI model, and it has a smaller training data set of 12,000 and using YOLO V3 model. And it only supports 10 species, including snow leopard, blue sheep, and other sympatric species. And here shows the general model performance. And like similar to the Tencent AI model, we find the model performance for such AI species identification is like the problems are pretty similar. So generally we have the highest accuracy for snow leopards, maybe because snow leopards, they have distinct patterns that make them look pretty different than other species. And for large and medium-sized animals, the accuracy is generally higher than the accuracy for small-sized animals like pika birds or Himalayan marmots. Yeah, and for this model, it only includes 10 species, and we are hoping to develop the model further to include more training data into the model, and also hope the model to support more species. And yeah, here are the two AI species identification models that we've been working with. And then moving on to AI-supported snow leopard individual identification, yeah, we have been discussing with our technical partners for the possibility of snow leopard individual identification by AI, but the general opinion is that such task is too difficult for AI to accomplish because the patterns of the snow leopards that we need to compare for individual identification is difficult. Is different in different situations. For example, if the angle or the amount of daylight, or if the fur is wet or not, such factors will all influence the patterns and making it harder to compare for the AI, not only for the AI but also for our human eyes. So basically, it's hard to conduct the snow leopard individual identification one step using AI. And as we discussed with Tencent, we figuring out another way to help us, like for AI to acting as a supporting tool for the manual identification process, is that using AI to identify the body parts, like AI to identify if a camera trap image captures the head of snow leopard, or the left part of the snow leopard, or the right part or tail or limbs of the snow leopards. And after such body part identification, here shows the individual identification user interface of the Tencent data management system. After AI identification, the system will directly put the images of same body parts together to help with the human identification. That means that you only need to compare the head photos together, and then compare the left part photos together, and then compare the right photos together. And then after the manual tagging of the individuals and accumulate data in the data sets, the model can iterate itself to have a higher accuracy, and also to improve the general snow leopard individual identification efficiency. Yeah, and above are the AI tools that we have been involved in developing, and here shows a more thorough camera trap data management platform that can combine the camera trap that can combine each steps in the camera trap data workflow, and help to provide a more a general database of camera trap data on the cloud. And here shows some of the existing platforms, such as Wildlife Insight, eMemo, Trapper, and Agoti. And we also have some platforms that have been developed by Chinese organizations, such as camera data and CMDS, and etc. And here I would like to briefly introduce two of the systems. The first is that the system that developed by Tencent, the Tencent Snow Leopard Conservation Data Management System. And this system, as I have already shown some of the system in the AI tools sections. The system has been already used in Qilian Mountains National Park, and also in Nachu in China. And also, and another platform that I would like to introduce today is the camera trap data management system that are currently under development by ShanShui. And yeah, these are some of the attempts for us to try to develop a thorough platform for camera trap data management. And we hope such tools can be useful for more for more conservationist partners that work on snow leopards, and also maybe provide some reference for these partners to develop data management mechanisms or systems that are suitable for their own needs. So for the Tencent snow leopard conservation management system, here shows a basic overview of the system. It includes the data management for camera trap, like including the image uploads and collecting camera trap, the trap info information of each camera traps, and for the camera trap images itself, it incorporates the AI tools to help identify the camera trap images and to support the further human identification. And also it includes data visualization functions, as shown here, to show some basic statistics. For example, the annual activity pattern and the daily activity pattern of each animals. Yeah, and the system is basically built on cloud, so so it can enable multiple users to collaborate using the system. And yeah, and here is the camera trap data management system that has been developing by ShanShui, and I'm here just showing the brief structure or the function designs of the platform, hoping this can provide some of the provide some reference for our partners working with camera trap data. So the platform includes generally four parts. So the first part is the in-field data collection, and we have developed a mobile app for the in-field data collection to help our local herder monitors to more conveniently record the data for each camera traps in field, like the GPS location and also the time for camera trap setup and pickup. And yeah, and moving on to the database construction, we have we plan to have a hierarchical data management system to include the trap info information, and for the data processing and also the media usage, we have for the data, we have another function model for data processing and media management. And then we have the data, like a very raw data visualization part to show the statistics and featured videos, featured images and videos. So for the database construction, we have a general data hierarchy, and we can search and we can import and export data from the system, and we can search and filter the data in the system. For example, we can know for each site how many camera traps we have, and for these camera traps, how many times of deployments we have, like how long trap days we have for these camera traps. And for the data processing process, as I introduced before, this platform can incorporate the whole process from AI identification and human identification that can allow multiple users to collaborate with each other, and then moving on to the expert review process. and it can also support individual identification. And here on the right shows the shows a example of the species identification page. So it shows the image preview on the top and the image itself, and you can filter, you can fill in identification results, and by referring to the existing identification results by AI and other human users. And for the media management part, the platform allows to search and download images and also add watermarks to it. For example, we can conveniently download the snow leopards. For example, the snow leopards in a village that are captured during 2020 to 2021. Yeah. And we have a very raw data visualization page that shows an overall statistics, like how many camera traps we have, and how many independent detections we have, and how many animals that have been the types of animals that have been identified from the camera trap images, and also showing some of the featured images or videos. Such a page could would be a very simple way to show the camera trap monitoring work. And another more complete, like a more detailed data visualization attempt that have been completed by us is that to generally show the biodiversity data, like using a map to show the locations of the camera traps, and some of the data results, for example, activity pattern, and some of the individual records of the snow leopards, and also some featured images. And this is an attempt for data visualization. And moving on to the tool utilization and future plans. So for the AI tools, the web tool, as I have presented, it currently has helped us to identify 870,000 images with more than 200 users. And here shows an example that how AI tools can help speeding up the celebrity identification process. Like it can help to shorten the manual identification time from more than 40 hours to approximately like 10 hours or even less. And for the data management platform, it will in the future will help assist us to manage the more than 1,000 camera traps that ShanShui has been deployed, and we're hoping such platform and tools can help more partners to help with the camera trap data management and processing, and to enhance the efficiency and help reducing the human labors that are needed for camera trap data management. And some of the future plans for us is that, first of all, as we during the development of such tools or systems, lessons we learned is that there is no perfect system. Like during the usage of system, different types of problems or bugs, they just appear, and we have for such problems or bugs we need trial and continuous improvement. So in the future, we hope to continuously improve these tools and try to open these tools for usage for more partners, or make such tools open source, that anyone who are interested in such tools can use such tools. And we will continuously collect user feedback and to support to help refine the tools and try to incorporate more AI models into the tool to help with the data processing, And we have more plans for tool development to include more function modules, and such as data visualization, data analysis, and also for citizen science to participate in the camera trap data processing more conveniently and in a more interesting way. And also and also another part of the future plan is to try to involve more intelligent devices, like using real-time transmission camera that can automatically record time and location, and also maybe the camera traps itself can incorporate AI identification modules in the camera trap device itself, so that we can have so after we retrieve the camera traps, we can already have the AI identification results, and as such we can speeding up the manual identification process and help to enhance the efficiency of the whole camera trap data workflow. Yeah, and basically that's it. Thank you for listening. Yeah, I think my explanation is it's not that good, and hope you can get some of it. And if you have questions, we can we are free to discuss. Thank you very much. I see there are many questions in the chat box, and Zheng-Yi has already answered most of them. Yeah, Zheng-Yi, do you have things to add for the AI tools or for the questions in the chat box?
No, I think, yeah.
Chunyue, there was one question asking what tools you currently use to do AI individual ID, since you do not use AI right now. What other tools are you using to tag photos or data processing before, or are you already using your AI tool?
I think some teams use DigiCam, and some other team maybe use other tools.
Yeah, basically, we haven't used a lot of AI tools for the Leopard individual identification, and currently the process is conducted mostly manually, and like using tools such as DigiCam.
Thank you. Great. No, that's good to know. Hopefully the other tools come first. But okay, so you're using DigiCam.
Okay, so we seem to be done. I think you both did a great job of answering all the questions. Thank you so much to both of you, and thank you for taking the time. That was a very, very interesting presentation for all of us. If anyone does want to get in touch with the ShanShui team, you can contact me via email, and I would forward your emails to them. And thank you so much for joining us today, and thanks to the ShanShui team for this excellent presentation. Thank you.
Thank you.